Hi everyone, Tina here, and today I'd like to talk about graph transformations. Some of this will be revision from GCSE Maths, so I'd recommend you watch my GCSE video on graph transformations first if you haven't already. A-level Maths has a few more transformations we need to be aware of, specifically stretching and squashing graphs in both the X and Y directions. Let's take a look at the rules first. I've split them out into two sections. So one is for a change in the Y direction, or a vertical change, and the other is for a change in the X direction, or a horizontal change. If we start with vertical changes first, this is when you have numbers or a negative symbol outside the brackets. For example, let's say we had y equals f of x and then plus 2 on the outside. That means we're going to move the graph up by 2. If we had y equals f of x minus 3 instead, that means we're going to go down 3. Both of those are transformations we should be aware of from GCSE. The new A-level transformations include these two that I'm going to show you now. So the first one being when you have a number, for example 4, on the outside of f of x. This means we're going to want to stretch in the y direction by a scale factor of 4. If you had a fraction or a decimal in front of the f of x instead, for example a half, this means you're actually going to want to squash the graph in the vertical direction. Or in other words, you could say you're stretching it by a scale factor of a half. So everything getting half as big as it was before. I've written here that transformation acts in the way you expect because all of those numbers correspond to moving up or down, stretching or squashing as you would expect. For example, a 4 on the outside, meaning you're going to stretch the graph by a scale factor of 4, so get 4 times bigger. If you have a minus on the outside of f of x, that's still a vertical change, so y changes, and that means you're going to want to reflect the whole graph in the x-axis. Let's have a look at horizontal changes now. If we have y equals f of x, and then this time the number or the negative symbol is inside the bracket, for example, plus 2 inside the brackets, that's actually a movement to the left by 2. If you had a minus 3 inside, that's actually a movement to the right by 3. If you had a 4 inside the bracket, that's in fact a squash rather than a stretch. Or you could say stretch by scale factor a quarter, or a squash, getting 4 times smaller but in this direction. If you had a fraction inside the bracket next to the x, so for example a half, that's a stretch this time by scale factor 2. So we're actually getting 2 times as big but in this direction. The comment here is the transformation acts in the opposite way to what you expect because, for example, when we had a half inside the bracket there, you might think the graph's going to get half as small, but in fact it does the opposite and gets 2 times bigger that way. If you have a minus inside the bracket, again, inside means it's a change in the x direction, so x changes. And this is a reflection again, but this time because x is changing, we actually want to reflect in the y-axis instead. Now we've seen the rules, let's take a look at some examples. Example 1, we have a sketch here showing the graph of y equals f of x. The curve has a minimum at minus 3, minus 2, and a maximum at 4, 7. Showing the coordinates of the points of intersection with the coordinate axes, sketch on separate diagrams the curves y equals f of x plus 2, and then y equals minus f of x. If we start with part I, f of x plus 2, that's a movement up by 2. The number is on the outside of the bracket, so it's a vertical change and y changes. Looking at that curve, if we move everything up by 2, that's going to end up looking something like this now. Something to note specifically is that minimum point was at minus 3, minus 2, but now it's going to be at minus 3, 0, so it's going to be sitting on the x-axis. The maximum point has also moved up by 2, so that's going to be 4, 9 now. And this is the graph of y equals f of x plus 2. Because we weren't given the original intersection with the y-axis in the question, we can't really see where that new intersection point is going to be on the y-axis in the translation. So it's good enough in this case to just give the new coordinates of the minimum and the maximum point. Part I, there's a minus on the outside of f of x, which means that's a change in the y direction. So we're going to reflect in the x-axis. So if we think about flipping the original curve upside down in the x-axis, that's going to end up looking something like this. In terms of the new coordinates, this is now going to be minus 3, positive 2, and this down here is going to be 4, minus 7. So again, the x's have stayed the same because it's a change in the y direction only, so only the y coordinates change. This is y equals minus f of x. Example 2. F of x equals x squared plus 4x plus 5. Part A. Express f of x in the form x plus a all squared plus b and state the coordinates of the minimum point of y equals f of x. Hopefully you recognize this format here as being completed square form. So we need to take our quadratic and complete the square. We have f of x equals x squared plus 4x plus 5. We complete the square, x plus 2 squared, and then I say minus 4 plus 5. So I'm using the shortcut method for completing the square, but you can do it however you wish. Then tidying that up, we get this. Remember, we can read turning points off of completed square form. So in this case, the minimum point is going to be minus 2, 1. For part B, we need to sketch the graph, showing the coordinates of intersection with the coordinate axes, which we can work out this time. I would probably start with the minimum point being minus 2, 1, so here somewhere. And then because we know it's a positive quadratic, we know it's going to be a nice symmetrical U shape. In terms of that point of intersection, you can work that out because you can say when x is 0 in the original function, then y, or f of x, is going to be 0 squared plus 4 times 0 plus 5, just giving 5. So that point there is 0, 5, and that's part B done. Part C introduces the transformations. So the first one is y equals 2 f of x. So that's a number on the outside of the bracket, so a vertical change. And in this case, a positive 2 means it's going to stretch by a scale factor of 2 in the y direction. It doesn't say that we need to sketch it, but I always prefer to sketch graphs when I can. So I'm going to draw a stretched version of the quadratic and think about what's going to change. So the minimum point, x is going to stay the same, minus 2, but the y coordinate is now going to be 2. Because it was 1 before, and now we're stretching by a scale factor of 2, so it's going to become 2. Thinking about that 0, 5 point, so 0 won't be affected, but 5 will. That's also going to be doubled. So on the new sketch, that's going to be 0, 10. So this is y equals 2f of x. And in terms of actually answering the question, so the minimum point is now minus 2, 2. Part II, the 2 is now inside the bracket, means it's a change in the x direction in the opposite way to what we would think. So instead of getting 2 times bigger this way, it's actually going to get 2 times smaller this way. So it's a squash. Quite hard to see that on a sketch, but we'll do it anyway. What's important is that minimum point there. So where it was minus 2 in terms of the x coordinate, that's now going to be half of that, or 2 times smaller, so minus 1. And then the y will stay the same as 1. And in terms of this point, 0 divided by 2 is still 0, so that will stay as 0. And then y is unaffected, so that would still be 5. This is y equals f of 2x, and the new minimum point is minus 1, 1. Last example, so we have another function here, and this time f of x equals x plus 3, x minus 1 squared. Part A, sketch the curve y equals f of x, showing the points of intersection with the coordinate axes. So in this case, f of x equals x plus 3, x minus 1 squared. Up to you, but I usually like to start with finding the y-intercept. So I would say when x equals 0, y is going to be 0 plus 3 and then 0 minus 1 all squared, which gives 3. So we know that there's going to be a point of intersection here at 0, 3. For the x-intercepts, when y equals 0, the whole function is equal to 0, meaning the x values are going to be x equals minus 3 or x equals 1. And that x equals 1 is a repeated root because we have the square brackets there, x minus 1 all squared. We can pop those on. That can be minus 3, 0, and this can be 1, 0. In terms of the shape of the graph, if you think about expanding that function, you'll see you'll end up with a cubic function, and it's a positive cubic, so something like this. If we sketch that on, we should get something like this. Remember, if you have a repeated root, the graph is going to come down and just touch the x-axis. And that's part A. Part B, find the equation of this time y equals f of x plus 2 in the form y equals x plus a, x plus b squared. Now you can actually answer this question purely algebraically. So if we start with f of x, original function was defined as x plus 3, x minus 1 squared. If we now do f of x plus 2, so replace the x with x plus 2, we'll get this. If you tidy this up, you get x plus 5 and then x plus 1 all squared. And that's the final answer. However, I just wanted to show you how that applies to our sketch. So as a bit of an extra exploration here, if you look at this new function, hopefully you can see that the roots would be x equals -5 or x equals -1 this time for the repeated root. If we were to sketch that on the same diagram as we had in part A, we would have one point of intersection here at -5, 0, and a repeated root here at -1, 0. Something like this if you sketched it. So you can see that actually the effect is that we're moving left by 2. And that could be a way of checking your answer, looking at the original transformation here, y equals f of x plus 2 inside the brackets. That in fact is a movement of left by 2. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks, and see you next time.